Good day everyone, welcome back to my channel. Today we are looking at the distance between 2 points. Now, for one to be able to start with this application, I would actually like to highlight a couple of things on this problem. Okay, now, first of all, let's assume we have our Cartesian plane. And we have our axis. In fact, I want to actually specifically draw a straight line here. And we have our axis. Remember, we have our x-axis and our y-axis. So we have our x-axis and our y-axis respectively. And then we have our actual figure. Our figure goes like this, or looks like this. In fact, before we have our figure, it will be very important in I highlight a couple of things here. Okay, so we have the values, or the measurements rather. So starting from this point here, point 1, 2, 3. Okay, similarly below 0 on our y-axis, we have 1, we have 2. Okay, those are our measurements. Okay, so now moving forward on this x-axis, same applies there. We have 1, 2, 3, 4, 5. Below 0 we have negative 1, 2, negative 3. Okay, so by indication of these values we have 1, 2, 3, 4, 5. We have negative 1 there, negative 2, negative 3, and so forth. Negative 1, negative 2, 1, 2, 3, and so forth. Now, let's now go ahead and indicate the actual Cartesian plane. No, yes, not the Cartesian plane as such, but the actual figure, right angle triangle. So we have at this point here, when x is negative 1 and y is 2, at this point here, this intercept there. Okay, now that's our a, and then when x is positive 3 and y is negative 1 at this point here. And then lastly, we're just given this intercept. So we'll have to figure out what that intercept is. Yeah. It's part of the question or the problem. So I just need to indicate this now. to now start indicating these values. So we have a here, and then the points are -1 by 2, and then this is b here. We have 3 by -1, and then we just simply have c. Okay. So now we need to identify other variables here. We have this side is, oh sorry, we have this side here is indicated as c, and then this side is indicated as b, and then this side here is a, or identified as a. Now we are asked to work on our own, and one should be able to use the theorem of Pythagoras to be able to do this activity. And then we are asked to let a be -1 by 2 and b to be 3 by -1 and be the end point of the line segment in the plane. So now we need to copy this graph alongside and complete the right angle triangle. So triangle ABC with AB is equals to C. Now, in other words, side AB is equals to C. And AC, or rather side AC, is equals to B. And CB is equals to A, of which I've already indicated with those variables here. So we have C, we have B, and we have A. Okay. Now we need to write the coordinates of C. Now to find the coordinates of C, all you need to do now, in order for us to find those coordinates, we're going to simply have a brace and then identify where does C, where X and Y intercept. So in this case, for X, remember, when you talk about the coordinate system, we have X and then Y, first X and then Y after X. So in this case, we look at X. X is actually at -1, and then Y is also at -1. So in other words, when C is at -1 and Y is also at -1. For X is at -1 and for Y is also at -1. So now moving forward, okay, just need to use a proper pen. Yeah. Okay, now we need to be able to use the theorem of Pythagoras to be able to find C. Now, to find C, we are asked to use the Pythagoras theorem. In this case, the Pythagoras theorem goes like this. It goes like this. Since side C is the hypotenuse, okay, remember that the original theorem of Pythagoras goes like this. r squared is equals to x squared plus y squared. Okay, that's the original formula for the Pythagoras theorem. Now, by substitution, we know that r squared is our hypotenuse, so in this case c is our hypotenuse here. So using the side formula or application, so we can actually now by simply saying side AB squared is equals to, now x in this case is CB, so we're going to have side BC squared plus, in this case we have now y in this case, or side y in this case is B, in this case we're going to have now AC squared. Now by substitution, AB, we don't know what it is, so we make it a subject of the formula. BC squared, we look at BC, we know that BC, this side here from BC, we are not actually given that side. Now, before we even move on to this, we need to find the distance. You used to use the distance formula. Okay, now I suggest now we start or reverting back, because we need to find the distance between the different coordinates. Now, okay, let's find the distance between A and B. Now, using the distance formula goes like this: D is equals to square root of x2 minus x1 squared plus y2 minus y1 squared. D, or distance, is equals to, now by substitution, because now we're looking at side AB in this case, you can just simply use that application. So now using the distance formula in this regard, so we have our coordinates. So our coordinates are, for x, we can just simply have -1 minus, so we have for B, x at B is 3, so I'm going to write B squared, okay, plus open bracket, so our y at A is simply 2 minus, and then our y at B, or point B, is -1, close bracket, and then raised to the second power. Remember, we are squaring this. Okay, so by calculations, so -1 minus -3, or rather 3, -1 minus 3 gives us -4. Okay, very careful. One needs to be very careful when calculating these values here. So we have 2 minus multiplied by -1 gives us 2 plus 1 raised to the second power. Okay, so D for distance is equals to -4 multiplied by -4 gives us +16. Okay, plus 2 plus 1 gives us 3 raised to the second power gives us 9. D is equals to 16 plus 9 gives us 25, and still squaring this, so D is therefore equals to 5 units. So D is equals to 5 units. So in other words, our distance, this point here, C, is equals to 5 units. That's our distance. Okay, that's what you are asked to find. To find the distance, rather, or the length of A, B, or the distance from point A to point B. is just simply 5 units. Okay, and then for question 3, we are asked, it says A, we have XA and IA, and then B, we have XB and YB are the endpoints of the line segment of the length D units of the Cartesian plane. Okay, so now what we did here, we just simply found the distance from A to B. Okay, we can go ahead to find the other distances, okay, or rather the lengths of these sides. Okay, we just need to find another additional length. Okay, we need to find another. Okay, now to find, remember this was 5 units, so I just have to be careful in clearing this. So C CF, this side here, say that it's 5 units. Now we need to find either A or B, side A or B, the lengths of A or B. Now to do that, we can also use the distance formula to be able to find that, and then hence now after that you can now simply use the Pythagoras theorem to find the last remaining side. So we can find the distance. Okay, I'm going to actually annotate it in this fashion now. So we're going to have XA minus, okay, let me just double check one last thing. In fact, let me avoid this for now. Let me rather stick to this principle of x2 minus x1 raised to the second power plus y2 minus y1 raised to the second power. The distance is equals to square root of, so we can either find the distance between A to C or from C to B, either way. So we can just go ahead and find from B to C then. So in this case, we're going to have now 3 minus, okay, x at B is equals to 3, and x at C is equals to negative 1. Close bracket, raised to the second power, plus, open bracket, y at B is equals to negative 1 minus, remember that's the part of the original function, okay, minus y at C is negative 1 as well. Close bracket, raised to the second power. The difference is equals to square root of, okay, by calculations, we have 3 minus negative 1, we have 3 plus 1 raised to the second power plus negative 1 minus negative 1 gives us negative 1 plus 1 raised to the second power. Difference is equals to the square root of, okay, 3 plus 1 gives us 4, raising that to the second power, open bracket, negative 1 plus 1 gives us 0, okay, so d is equals to square root of 4 times 4 gives us 16, b is equals to, when you square 16, remember now 0 times 0 just simply becomes 0. So we have 0 here essentially. Okay, so 16 plus 0 is equals to 16, and you square 16 gives us, simply gives us 4 units. So in other words, the distance between BC is equals to 4 units. Now, to use our Pythagoras theorem, we can just simply say r squared is equals to x squared plus y squared. So we already have our r squared, which is this case 5 squared is equals to x squared. In this case is 4 squared plus y squared. That's what we need to find. We make it the subject of the formula. So we have 5 squared minus 4 squared is equals to y squared. Okay, so we remain now with y squared is equals to 5 squared gives us 25 minus 4 squared gives us 16. Y squared is equals to 25 minus 16 gives us 9. When you square on both sides, the square will fall off. We just simply remain with y, and then the square root of 9 gives us 3. So in this case, b is equals to 3 units. So we found y to be 3 units. And that brings us to the end of our presentation for today. Thank you for watching. Please like, share, and subscribe to my channel so that I can create more of these educational videos. Thank you for watching. Goodbye.